Okay, question 5. We've got a classic straight line, don't we? So equation of the line, you should definitely be thinking to yourself, P, G, E. What point have I got? What's my gradient? And from that I can get the equation. So I should be thinking, well, the point, that's negative 2, 0. So that'll be the A and B that I use when I come to do y minus b is fx minus a. And how do I get the gradient? Well, the gradient is usually from 2 points, which I don't have, or it can be the perpendicular gradient from another line, don't have that. What I do have is an angle. So this is obviously looking at m is equal to tan theta. So the angle you want, don't forget, is this angle in here. That's the angle for a gradient, yeah? Because that's the angle that's relative to the height and the length. Don't forget, gradient, m equals y2 minus y1 over x2 minus x1. y2 minus y1 is just a fancy word for height. And the difference in the x's is just another one for length, isn't it? It's like the ratio of the height over the length. And if you look at that, the height relative to this angle x, that's opposite, and that's adjacent. So opposite and adjacent, and that's why it's the tan function, okay? So you want to make sure it's this angle here, not any other angle, because it has to be the ratio of the height to the length. Okay. So if that was a negative line coming in over here, like this, we would work out this angle and look at this height, this height versus this length, okay? And then say what's negative, so you'd physically call it negative. You might work out a gradient here of 2 or 3 or 4, and then say, well, it has to be negative 2 or 3 or 4 because of the direction. Okay, so that's how we think then. Pi over 3, what is that? What is that? Well, I'll maybe rub, yeah, I'll just put a wee line here just to keep that separate. So I always think 2 pi is 360 degrees. So pi is 180 degrees. So pi over 3 will give me 60 degrees. So I know that this angle in here is going to be the same as that. That's going to be pi over 3 as well, because of your alternate angles are the same. So that's 60 degrees. So if that's 60, this in here is going to be 90. That means the angle I'm looking at is 30 degrees. So you could state that as radians or whatever. I'm not sure if they're that fussed, to be honest, but that'll be pi over 6 is 30. So I'm looking for the gradient for tan of pi over 6. 30 degrees. So exact value triangles. I've got a 30, I've got a 60, I've got root 3, 1 and 2. So my tan theta is the opposite. There's my 30 degrees. So the opposite is 1 and the adjacent is root 3. So it's 1 over root 3. Catch up. I should really have said tan of. Again, so let's catch up. Tan of pi over 6 is 1 over root 3. So that's your gradient. Fantastic. Again, I'll just put a little separating line down here. And then we're into our equation. So y take away 0. Wow, it's really slow. I mean, it's quite late, but I thought computers were, good to go, but never mind. Times that by root 3. So that's just x plus 2. And I think I would just leave it like that. So let's have a look at the marking scheme. So we've got 1 over root 3 is getting us 2 marks because we've had to do the tan 30 or tan pi over 6. So they weren't fussed if you did it in degrees or not. That's good to know. I think they are for definitely integration has to be all the way through. I'm not sure about trig. But yeah, for this one, they don't seem to mind. So if you do straight line, looks like they don't mind if you do it in radians or degrees. So you get a mark for knowing this, i.e. solving your triangle, mark for your gradient, and then a mark for your final answer. You could have divided through by root 3 as well, if you wanted, but this is fine. So yeah, PGE, and don't forget your m tan theta. This is probably the trickiest form, I think, of the straight line question. But when you think about it, it's not too bad. Okay, just try to make life a wee bit trickier, as long as you know you've got this angle. So a little curveball there, but still plenty of marks to be had. You would get follow through, I think, if you made a mistake with that angle. All right, so remember PGE and M tan theta.